Hi everybody, we're starting a new unit on functions, and so this video is about some basic vocabulary for ways that we can represent the x part of the function and the y part of the function. So you will need this vocabulary list to do your assignments for the rest of the day. So x, we can also refer to that as the input and y is the output. Domain is all the x's, range is all the y's. X is also called the independent variable and y is called the dependent variable. So if you remember on a graph, an ordered pair is written with the x number first and then the y number. And so the x number tells you how far to the right or the left, and the y number is how far up or down. And so I only did a positive one, but if you go to the left, it would be negative. If you go down, it would be negative. And that helps us figure out what quadrant to plot points in. So x is also the horizontal axis, the one that goes left to right. Y is the vertical axis, the one that goes up and down. And the way that I kind of have a trick to remember is if you make a capital Y, if you make it with like the little V shape at the top and then the stick attached to it, that is kind of like the y-axis and what it looks like, that up and down. So use that trick if you forget which one is the x and which one is the y. When you see numbers on a table, the first column is the x, the second column is the y. If I make my table going across, then the top numbers are the x and the bottom numbers are the y. Alright, so what you need to be able to do today is basically just interchange x's and y's for domain and range, input, output, independent, and dependent. So I have a scenario here, and our goal is to figure out what part of the story can we use for x and what part of the story can we use for y. So we have the cost of buying tomatoes that are $2 each. So when you're thinking about independent and dependent, think about what depends on what. Independent is something that you are like plugging in, and whatever the output is your dependent or the y. So if you're thinking about your grocery cart at the cash register, like you're handing the cashier tomatoes and the cashier is telling you how much money you have to spend. So the input is how many tomatoes you're buying, because the output is what the cashier is telling you, which is your total cost. So if I was to graph this scenario, the number of tomatoes would be my x, and the cost would be my y. So I could figure out, all right, if I have 3 tomatoes, how much is it going to cost me? And so the number of, the total cost, so the amount of money that you're going to have to spend at the grocery store, depends on the number of tomatoes you buy. So that means tomatoes is our x, and the total cost is our y. So the cost depends on how many tomatoes we buy. That means the cost is the dependent variable because it depends on something else. You can also kind of think of it as a cause and effect relationship. The number of tomatoes that you buy is going to have an effect on how much it's going to cost you. All right, so there's multiple ways to think about it. Input, output. You're putting tomatoes in your basket. The cashier is telling you out loud basically how much it's going to cost. Or kind of read it as a blank depends on blank, or what is going to have an effect on something. All right, so the domain is your x values. So that would be how many tomatoes we're buying. So let's just think of a few numbers. I mean, technically I could go to the grocery store and buy no tomatoes. I could buy 1, I might buy 5. I don't really think I would ever need to buy much more than that. But your domain is how many of whatever your x stands for you would buy. All right, so your range is the y. So they kind of have to match up. So if I buy 0 tomatoes, I can expect to spend $0. If I buy 1 tomato, well, they cost $2 each. So if I buy 1 and they're $2 each, I'm going to have to spend $2. If I buy 5 and they're $2 each, then 5 times 2 is 10. So your domain is what you could use for your X, and range, they have to match. So you shouldn't just be making up random numbers. You should think about, all right, if I plug this into the story, what would my outcome be? What is my output? All right, let's do another example. So a painter needs to know how much paint to buy for a house. So what depends on what? Well, think about that same input-output, cause and effect relationship. The size, oh, no, sorry, I did it backwards again. The number of paint cans that the painter is going to buy depends on the size of the house. Right? The size of the house can change. Someone could have a small house, someone could have a really big house, but the painter kind of needs to know how big the house is before they know how many cans of paint that they're going to need. So that cause and effect relationship. First, they're going to figure out how big the house is, and that's going to affect how many cans of paint they're going to need. So the number of cans of paint depends on the size of the house. So the size would be our X, and that would probably be something like square footage, something like an area type of a unit, and the number of cans of paint would be the Y. All right, so for this we don't have enough information to try to actually figure out what our domain and range would be, but square footage, however big the house was, that would be numbers that were in the domain. That would be the input, and the output would be how many cans of paint they're going to need to buy. Because think about if you switch it, I mean, if you were a painter and you bought 25 cans of paint and then you measured the house and you realized you only needed 5 cans of paint, that would be a waste of money, right? So think about whatever information you kind of need to know first is your X, and then what are you going to do with that information? And that's going to be your Y.